Good evening. I'm here to present my seminar Wearable Pressure Devices guided by Assistant Professor Anujodi of EC Department. These are the contents to my presentation and we will be going through each in the upcoming slides. One of the most significant impacts that affect health adversely during the treatment of cardiovascular diseases is high blood pressure. One third of all the deaths occurring worldwide is also due to cardiovascular diseases such as ischemic diseases and stroke. Ischemic diseases are actually weakening of heart due to low blood pressure. Thus, as a cure, various pressure sensing devices are developed and are under development. Therefore, wearable pressure therapy comprises of a wide range of pressure sensing tools that deliver therapeutic pressure and inform the user when immediate medical attention is required. Coming to the history, in 1980, first wireless ECG was invented. In 2002, Respirate, a device which slows down breathing rate and reduces hypertension, was introduced. In 2010, a device to obtain the pulse wave data, which again uses a Hall device, was implemented. In 2013, a vital patch, which is actually an adhesive patch, which is exactly used for detecting pressure, was introduced. In 2019, the first clinically approved smartwatch specifically implemented for BP monitoring was introduced. In 2021, BioBeat, the latest ambulatory pulse monitoring device, was introduced. In 2023, there are various ongoing researches regarding ultra-thin sensors. Wearable pressure devices. These are exactly a form of portable devices which can be further classified into wrist mounted devices and head mounted devices. Wrist mounted devices are commercially systems for physiological monitoring that has been created with longer lasting batteries and small electronics. It helps in turning unprocessed signals into data that can be interpreted in real time. A photoplethysmography sensor is actually used in many of the wrist-mounted devices. Coming to the head-mounted devices, smart glasses made by Nicholas Constant are pulse-sensing glasses with a photoplethysmography sensor on the nosepad to continuously monitor heart rate. Wearable smart glasses are a type of head-mounted computer that displays information. One of the major wearable pressure devices is Respirate. It was found on 2002 and was approved by FDA. It is a wearable device that produces proper pressure therapy and is termed as Respirate. It actually consists of a main controller, which is MSP430 controller, and a sensor, then an elastic band and the main programming code. The elastic band and the sensor is actually placed on the upper abdomen of the user according to the breathing pattern. The controller has a certain codes and programs that has certain chords and tones for reducing the BP. Users listen to a melody through the headphones that guides the listener to slow their breathing rate. Thus, this device can be actually considered as a device which provides proper pressure therapy to the user. Next is E4 Smart Wristband. It is an unobtrusive device which has a 3D accelerometer sensor, an EDS sensor, a skin temperature sensor, and a PPG sensor. The main features are unobtrusive monitoring, clinical quality observation, ability to see data anywhere, and provides developers with raw output data. The signals from various sensors are fed into the artifact detection unit. In artifact detection unit, various features are detected. Artifacts are actually unintended features present in blood. These features are converted into signals and these signals are detected in artifact detection unit. In artifact removal unit, various artifacts are removed using various set of codes and machine learning and other programming. And then in feature extraction method, in feature extraction, the various features from the from various sensors are extracted and these sensors are further used to clean the EDS signal. The machine learning classifiers and others help to detect stress and physical activity and help to reduce this. There is a high level block diagram of this proposed system that is presented in the screen. Here comes the disadvantages of E4 smart wristband. It provides lower data quality than medical grade devices. It is more sensitive to unrestricted motions in daily life, and it's approximately costly, 1,690 US dollars. Coming to the features of wearable devices, it has a multi-sensor capability. That is, multiple sensors can be incorporated in these devices to get multiple data. Then data resolution. Proper resoluted data can be obtained from these devices, and these data comes in unit like Pascal. Next, alerts and notification. It can provide alerts and notification, customized notification and alerts, so that the user can immediately identify whenever the BP is high or low. The operation of these devices are actually simple, and they are miniature in size. They have ability to store data in and analyze the data efficiently. Next is optical sensors. Many of the wearable devices uses optical sensors as the main sensors. For example, a photoplethysmography sensor. And last is wearability and portability. Coming to the various methods of measurement of BP using various sensors. First one is oscillometric finger cuffs. Oscillometric finger cuff is a device used to measure blood pressure. It works by inflating a cuff around the finger and then measuring the oscillation in blood pressure as the cuff deflates. These oscillations are caused by expansion and contraction of the arteries as blood flows through it. The cuff is connected to a sensor that converts the oscillation into electrical signals, which are then processed by a computer to calculate systolic and diastolic pressure. A sensor measures the oscillation in blood pressure and converts them into electrical signal. Next is photoplethysmography itself. It is a non-invasive optical technique that measures volumetric changes in blood in peripheral circulation. It is a low-cost and easy-to-use method that makes measurement at the surface of the skin. The technique provides valuable information related to a cardiovascular system. It works by emitting light into a tissue and then measuring the amount of light that is reflected back. The amount of light that is reflected back is proportional to the amount of blood flow through the tissue. Mainly, we can see that many smartwatches includes a green LED light which is fed into the surface of the skin. Green light is easily absorbed by the blood, thus it is used, and a certain amount of light is reflected back. Next is applanation tonometry method. It is a non-invasive method for measuring intraocular pressure, that is IOP, which is the pressure inside the eye. It is considered as the gold standard method of IOP measurement due to its accuracy and reliability. It states that the pressure inside the spherical is equal to the force required to flatten a specific area of its surface. The force required to flatten a specific area of the cornea is then measured, and this force is used to calculate the BP. Next is integrating photoplethysmography in smartphone applications. The integration of photoplethysmography technology in smartphones has the potential to revolutionize healthcare by providing users with convenient and accessible tools for monitoring their cardiovascular health. By utilizing the built-in cameras and processing power of smartphones, PPG sensors can measure various physiological parameters including heart rate, blood pressure, and oxygen saturation without the need for bulky and expensive equipment. Coming to the technology behind latest pressure devices. Wearable pressure devices typically uses sensors like optical sensors, acoustic sensors, and force sensors. Optical sensors use light to measure BP. Acoustic sensors use sound, and force sensors use force. Coming to the latest, one of the latest wearable smartwatch. Apple Watch SE has a faster processor, that is S8 SIP with 64-bit dual core and a storage of 32 GB and a second generation optical heart sensor and a better battery life of more than 20 hours than many of its previous models. Various other components include general microcontrollers, communication modules, and power management modules. As we all know, microcontrollers are used to control the sensors and other electronic components in wearable pressure devices. Communication modules allow wearable pressure devices to communicate with smartphones, computers, and other devices. The power management modules are responsible for managing the power consumption of wearable pressure devices. The other elements are batteries, displays, and enclosures. Another specific electronic component used for various wearable pressure therapy, which can be considered as an important wearable pressure device, is Omron heart guide. As I have already mentioned about it in the history, it is a monitor that uses an optical sensor and a Nordic semiconductor NRF 52832 microcontroller to measure blood pressure continuously. It has various features. I mean, the microcontroller. It is a 32-bit ARM, 64 KB RAM, 1.7 volt to 3.6 volt supply voltage. The wristband actually works on the principle of oscillometric method. That is, it has a cuff which inflates and it compresses the walls of artery, and there will be a particular variation in the blood pressure, and whenever there is a slight or a large variation in the blood pressure, it will be detected and immediately medical requirements can be done. Coming to the ultra-thin wearable pressure sensors, these are new and emerging technology. These sensors are typically made of flexible and biocompatible materials. Now, a few companies are developing smartwatches with this technology, and one such as Samsung. The technology behind ultra-thin wearable pressure sensor is basically on the principle of piezoelectricity, and the cost is approximately 599 rupees. Coming to the various important sensors used in wearable pulse pressure monitoring. First is piezoresistive with the feature of simple structure, high resolution, wide response range, serious hysteresis, and other features. Next is capacitive. It has high temperature stability, low electrostatic gravitational force, good dynamic response, high impedance, poor load capacity, etc. And next is optical sensor. As I have already mentioned, it is a light sensor, that is, it emits light to the surface of the skin, and a certain amount of light is reflected back. Whenever there is variation in the amount of light reflected back, it will be monitored exactly by the device. Next is piezoelectric. It works on the basis of piezoelectricity. It has a wide frequency response range, high sensitivity, high signal to noise ratio, simple structure, and dynamic signals only. Next is triboelectric. That is, whenever two materials are rubbed together, there will be variation, and the BP can be monitored using this. It also has high sensitivity, simple construction, and various other features. And last is magnetoelastic, which works on the principle of magnetoelasticity. Comparison of pressure sensor performances. Ultra-thin sensors with a response time of 2.5 milliseconds, sensitivity of 13.4 kilopascal, and piezoresistive with structure nanowires and semi-cylinder, response time of less than 17 millisecond and 30 millisecond, sensitivity of greater than 1.14 kilopascal and 3.6 kilopascal, and stability of greater than 50,000 cycles and 10,000 cycles. Coming to piezoelectric with structures interlocked and sandwiched, the response time of 53 millisecond and less than 200 millisecond, sensitivity of 3.12 millivolt per pascal and 35 milliampere per pascal, and stability of 5000 cycles each. Coming to capacitive sensors with structure micropyramid and line, response time of less than 10 millisecond and less than 100 millisecond, and sensitivity of 8.4 kilopascal and 1.9 kilopascal, with stability of greater than 15,000 cycles and 1000 cycles. Various sensors including capacitive sensors and their specification. Capacitive sensor with power supply of 2 to 5.5 volt DC, frequency range of DC to megahertz, and price approximately 99 rupees per module. Coming to piezoresistive sensor, power supply 3.3 to 5 volt, frequency range DC to kilohertz, price 500 rupees for AS60 module. Piezoelectric sensor, these sensors are actually self-powered sensor, but coming to talking about the module, it has a working voltage of 3.3 to 5 volt, working current of 1 milliampere, and price of 241 rupees per module. The main impact of machine learning. The fact that BP is influenced by a variety of factors has driven researchers into use of machine learning technology to extract various optimal features required to monitor BP and develop algorithms. The central concept is to examine the time domain and frequency domain from physiological signals to extract BP-related features, and then use machine learning to eliminate unwanted features and calculate BP from optimal data. The most common learning algorithms evaluated in the development of BP models to data include neural networks, linear regression, support vector machine, random forest, and deep learning. As we know, time and frequency domains helps to extract various features and to have a major impact in the pressure detecting devices. Research prospect: flexible pressure sensors with a low detection limit and a quick range speed, high sensitivity, high sensing range are under development. Researchers are also developing new technology to improve the accuracy and reliability of variable pressure sensors. Unique and better knowledge of the process should be studied in order to produce an enhanced performance pressure sensor with regard to overall performance matrices. More advanced smart algorithms must be developed in order to provide successful validation of healthcare data from heterogeneous devices in personalized healthcare environments via the Internet of Things. Coming to challenges, wearable devices can clearly provide data that are personal to user needs, issue, and concern. However, the extent to which the individual users can access these data is very limited and it seems to be unequally distributed. Most wearables available on the market are developed and sold by large corporations such as Apple or Google, which will be very hard to afford. The health equity contextual information on the collection, classification, interpretation of wearable data is usually not shared by data providers and device manufacturers. This is an issue for health equity. So these are the solutions. More access to data can partially counter the economic and political power of technology corporations. The specific use and position of wearables as digital health technology need to be openly and critically discussed to ensure that those who choose not to be a part of the movement are not unequally treated and lose access to other health services. For health equity, however, access to technology should be approached critically in light of consideration of the specific social and political context of use. These are the various applications of wearable pressure devices: real-time monitoring of physiological signals, monitoring chronic health conditions, aiding the early diagnosis of diseases. Wearable therapeutic system can reduce patients' health risk and long-term medical cost, improving fitness and performance. People with chronic health condition use wearable pressure devices to monitor their condition and to identify any changes that may require medical attention. Researchers are using wearable pressure devices to collect data on a variety of health conditions. These are the various companies involved: Omron Healthcare, Apple, Fitbit, the Philips. Omron Healthcare, founded on May 1933, headquarters at Japan. As I have already mentioned about Omron Heart Guide, they provide a wide range of smartbands and other equipments which help to detect blood pressure, um, and they will be more accurate and reliable. Next is Apple, founded on April 1, 1976, headquarters at California, US. Apple also has a wide range of smartwatches, which is actually quite expensive, but reliable and accurate data can be obtained from these smartwatches. Fitbit, founded in March 2007, headquarters United States. They also provide a wide range of smartwatches, which can provide proper heart rate and BP rate, and can be used as a therapeutic device. Next is Philips, founded on March 1891, headquarters at Netherlands. Philips has a wide range of BP measuring devices and machines, which is actually used in many of the hospitals these days. As not only smartbands and wristbands, they have various machines, affordable and portable machines that can be used to detect BP. Coming to the conclusion, wearable BP monitoring devices are considered as the technology of the future. These approaches provide a realistic prospect concerning the goal of reducing or even eliminating cardiovascular events in hypertensive patients. The availability of simple and affordable devices for reliable cuffless BP measurement allows the diagnosis of hypertension at an early stage, which helps in improving the BP control, but also significantly increases the use of remote monitoring in the management of hypertension. Thus, we can conclude by saying that using these devices will be actually cure to most of the blood pressure occurring and device and diseases, as these can be actually considered as therapeutic devices which can provide proper pressure therapy and can be used to provide immediate medications to the user whenever the BP is high or low. The low profile and portable devices allows for mobility during treatment of hypertension, addressing barriers to adherence with PCDs. So these are the various references. Thank you.